Okay, now girls, when you factored 16 minus x squared, what did you get? And again, shout it out, that's fine.
X plus 4 times x minus 4.
I heard, that's too many fours.
I think that it is, plus x times 4 minus x. Yeah.
Okay. There we go. Okay, and it's important to have the x's listed second because x times negative x is negative x squared, and we have a negative. Okay. All right. So great, we got it in factored form. Now, girls, if I plugged in -4, what did I get for y?
0.
Oh, that's not what I wanted to do. 0. Okay. If I plugged in -3? 2?
7.
When I plugged in -1? When I plugged in 0?
16.
When I plugged in 1?
15.
2? Oh, it's symmetrical. I love parabolas because you only have to do half the work. That's much nicer. All right, so now we're going to connect the equations with the important points. The x-intercepts, the y-intercept, the line of symmetry, and the vertex. All right, so boys, and this is a boy question here. What were the x-intercepts? Anybody?
6 and 0.
6.
0 and 0.
0 and 6.
Yeah.
Because it's the x value, right? Okay. So the x-intercepts were 0 and 6. All right, so I'm going to ask in a moment which equation, factored or expanded, is it most obvious in, but I'm going to ask the same question of the girls first. Girls, where are the x-intercepts in this table?
-4 and 4.
-4 and 4, right? When y is 0, okay. So notice how at the x-intercept, the y value is always 0. Does that make sense so far? That's an important part. So, where is it easier to see in the girls' problem? In the expanded form expression or the factored form expression? Which one is easier to see intercepts of -4 and +4? Factored or expanded? Yeah, 50-50 chance. Factored. It's much easier to see in the factored form. Here is what is happening. Here is what is happening. The first thing that is happening is I don't know where my square went. So I'm going to build a new square. What does the square have to do with anything? Well, I need it to cover stuff up. There we go. Okay. So I need to bring it up to the top page. Okay, so top layer, here we go. So girls, here's what's happening. And boys too. So we are going to say that at the x-intercepts, the equation is equal to 0 because it's always 0 in all of them. Does that make sense? Okay, so here's what's happening. We are multiplying two numbers together. And when we multiply those two numbers together, we get a product of 0. That can only happen if one thing is true. What can you say about one of the two numbers? You're multiplying two numbers together and you get a product of 0. What has to be true about one of the two numbers?
One number has to be 0.
Yeah, one of the numbers has to be 0. So, I'm just going to cover that one up. 4 plus x is equal to 0. Well, okay. What does this x have to equal in order to make that a true statement? 0, no, because 4 plus 0 is 4. That's a common knee-jerk reaction. What? 4 plus something is 0. What's that something? -4. So that's where we get this -4 right here. If I do the same thing over here, let's cover that up. 4 minus something is 0. What's that something? That's a positive. That's our positive form. Oh, so that's where we get this one. Boys, the same thing's happening. Same thing is happening. If in the factored form, what number will make that x 0? It's not a trick question.
0.
0. So that's where this 0 comes in right here. If I slide this over, what will make x minus 6 equal to 0? 6. So that's where we get this 6 from. So the factored form expression will give us the x-intercepts. All we did is we figured out what x had to be in order to create a 0 for each binomial, or monomial as the case may be. So the x-intercepts are found in the factored form. And that's why we're going to spend so much time finding factored forms of expanded questions, because that's how you get a solution. You have to have a quadratic in factored form to get a solution. All right, so now let's talk about the y-intercepts. Boys, where do you see the y-intercept in your table? This is, again, a shout-out experience.
0.
0. And it's, in this case, it's this 0. All right, girls, where do you find your y-intercept?
16.
16. Okay, so again, this is easier to see in the girls' equation than the boys' equation. Where do you see 16 in the equation? Is it the factored form or the expanded form?
Expanded.
It's the expanded form. So the y-intercept is always in the expanded form. Now, here's the thing. I'm going to go off on a little tangent, but not a big tangent. A little tangent. So if I have an equation, let's say I have y is equal to x squared plus 4x, I don't know, minus 12. So each of these terms has a name. This is vocabulary. Yes, you need to know this. Yes, it goes in vocabulary. This part right here is called the quadratic term. It's called the quadratic term because if you graph it, you would get a parabola. Because y equals x squared is a parabola. This term right here, and you've heard me say it over and over again. Does anyone remember what this is called? I don't think I formally said it, but this is called the linear term. Why is it called the linear term? Because if I graphed it, I'd get a line. This term right here, this is called the constant. It's called the constant because it doesn't change. So your constant is always going to be your y-intercept. What's the constant here? What am I adding to this equation here? What can I add that's not going to change the value? It's not a trick question. What can I add to something? 0. Okay. Do you agree? Have I changed this equation? No, not at all. So that's why the y-intercept is 0. Okay. All right, so here I'm going to skip the line of symmetry for a moment and then come back. Doing okay? Okay. You're choking on your own saliva? I've done that quite a bit. And nowadays, if you start having a little cough, everyone starts staring at you like... Yeah, because there's definitely a stigma with coughing. Yeah. All right, so I'm going to skip the line of symmetry for a second and go straight to the vertex. Boys, what is the vertex of this relationship?
-9.
Close.
-9.
Close. You're real close. We're looking for a coordinate point.
3, -9.
There you go, 3, -9. Girls, what is your vertex?
0, 16.
0, 16.
0, 16.
So your vertex also happens to be the y-intercept, and that's okay. All right, so we said it's right here. So the line of symmetry is simply the x value in the vertex. So what is the x value in the vertex for the boys?
-9.
That's the y value. Try again.
3.
3. Okay. Girls, what is your x value in your vertex?
0.
0. Okay, so here's the big question. What's the connection between the x-intercepts and the line of symmetry? What is the connection? In relation to the x-intercepts, where can you find the line of symmetry?
Directly in the middle of the two?
It's directly in the middle of the two. You are absolutely right. And that's what I was looking for. So the line of symmetry is simply the average of the two x-intercepts. So, 0 plus 6 is 6, divided by 2 is 3. -4 plus 4 is 0, 0 divided by 2 is 0. That's it. So then all you have to do is take this value and plug it into your equation and you'll get the y value. That's all you got to do, just like the table. All right, so are there questions about the connection between the equations and the important parts of a parabola? Because this is the time to ask. Okay. Yes?
I have a question. You said that the something about the LOS and how does that correlate with the y-intercept?
It doesn't. I did say, however, that on the girls' equation, it just so happened that the y-intercept is on the line of symmetry. And actually, that will happen for all differences of squares, but it will only happen for differences of squares. There's normally no connection between the line of symmetry and the y-intercept. Are there any further questions? Okay, so here's what we're going to do, and I'm going to keep this in the video for the instructions. So your job is not to make a table. Your job is not to make a graph. Your job is to create this table right here. I know it's hard to see. I'm purposely trying to keep it not very obvious, not as blinding. So you're just finding the x and y intercepts, the line of symmetry, and the vertex. That's all you need to do. To help you do that, I'm going to highly recommend that you use Desmos.com. I know that I have mentioned Desmos.com before. How many of you if you feel comfortable using Desmos, by all means, go to your small common rooms and you can get started on the rest of part A. So for part A, you're simply making that table for the important parts for 3, 4, 5, and 6. Question B, 1, and 2, 3 are going to be homework. Okay? If you do not feel comfortable using Desmos, please stay here and I will show you how to use Desmos. So if you feel good with Desmos, get working on the investigation in your small common room. If you don't feel good about Desmos, stay here and I will show you how to use Desmos. Okay, go.
Mr. Bradley,
Yes.
you're saying we don't have ACE tonight, just the...
No, there are going to be a small number of ACE, just not as many.
Okay, thank you.
And there's also a video explaining how to do B. All right. So for those of us who are a little not so hot with Desmos, that's okay. So what I am going to do is I'm simply going to start from scratch. I'm going to type in Desmos graphing.com. And this, there are several different graphing applications that teachers use, but this is by far the most common. So go ahead and hit Graphing Calculator. Now, incidentally, DPS does pay for you to, your DPS Google account does allow you to have an account on Desmos if you ever want to save stuff and log in. I believe that should work because I know teachers have that. All right, so then all you need to do is type in the equation. Now, I am a sucker for factored form expressions, so I'm going to go ahead and type in a factored form expression. And I'm just going to make it up as I go along. X minus 5, so that has a x-intercept of positive 5, because it's always the opposite of the term. And x plus 3. So that has a y-intercept of negative 3. So, and that gives us our graph. And so I can zoom out by, or in. Gives me a headache. Woohoo. And you do that by, with your two fingers in and out. You figure it out. All right. And so once you have your graph, if you want to customize your how much you see, you can change the values here. I don't really feel the need to do it, but whatever. Why not? So my x-intercepts are not nearly that big, so I'm going to go with negative 5. And let's go with, oh, I don't know, 8. And that, no, I wanted negative 5 for, geez. Negative 5. There we go. All right. So if I click on the graph, it turns a little redder, which is nice because you can graph multiple graphs at once and they'll just be sort of ghosted a bit if you're not looking at it. Now, once I clicked on the red graph, notice how I got these dots. And if I hover over the dots, these dots are the important points. And they tell you the exact coordinates of the x-intercepts, the y-intercept, and the line of symmetry. Woohoo! That's pretty much it, folks. Now, the trick here is we are looking for the connection between the equations and the important parts. So when you're finding your factored and expanded forms, you should be thinking, okay, what is that going to give me for the x-intercepts? What is that going to give me for the y-intercepts? For question B, you're to get that little table without using Desmos. Are there any questions about how to use Desmos?
How are we supposed to put in exponents?
Okay, so to put in exponents, here is what I do. So you go y equals, and let's say we have x squared, because it's almost always x squared. So I type in x, I'm now touching the shift key, and I touch 6 to make that little caret, and now it's above, and I put 2. And then notice how my cursor is still in the exponent. I then have to hit the down arrow so that my cursor gets out of the exponent, and then I can do the rest of my equation.
Okay, thank you.
Okay. All right. Are there any other questions about Desmos? Okay, it's time for me to stop.